Hello. So, in this video we are tackling yet another of our factoring techniques. So this time we're doing the AC method. So what is the AC method? Well, we've looked at quadratic forms, and in particular quadratic polynomials, where we had this ax squared plus bx plus c, and a was 1, right? We did our coefficient method. But sadly, that's not how life always works out. We don't always have a being 1, and so the AC method is usually used for situations where a is not 1. Now, to be clear, technically we also want a to not be 0, because if it were 0, this wouldn't be a quadratic. We wouldn't be doing any of this work. It would be already factored. So we say a not being 1. We also mean a, existing and not being 0 too. All right. So in particular, AC method, that's what we're using when a is not 1. Our goal is to split up the b term, right, the coefficient in front of just the regular x, and we want to split it in such a way that we can then factor that now 4 term, right? If we split the b into 2 terms, we'll have 4 total. We want to be able to factor those 4 using factor by grouping. All right, so how do we do that? Let's look at an example. So here we have 6x squared plus 19x plus 15. So obviously, right, a is not 1, a is 6. So step 1, we want to multiply those a and c terms together, hence AC as an a times c, AC method. So we multiply those together, we get 90. Now we're going to sort of pretend that we're doing some sort of factor by group, but some sort of coefficient factoring using that part, the 90, and the current b term, 19. So in particular, we want 2 numbers that factor to 90, but then add to 19. So we write out our factors of 90, and we see, okay, 9 times 10, that's 90. Add them together, we get 19. That's my pair. But what I actually am doing when I do that is I'm identifying what it is or how that I want to split that b term apart. So when I see 9 and 10, what that tells me is I want to rewrite that 19x as 9x and 10x. And this works even if we had a negative, right? So if we had, for example, positive 1x, and thus, we had negative 90, and so we were looking at the, say, negative 9 and 10, that would tell us that we want 1x written as 10x minus 9x, right? So we're replacing that middle term with these two. So in our case, it looks like this, right? We have our 19x, and then we're replacing that 19x with this 9 and 10x added together, right? 9x and 10x. And if you're ever not sure whether you did it right, it's sort of easy to go back again and be like, okay, if I add these two together, do I get back to the original b term? Because that's what it should be, right? But now that we've split that b term, in theory, right, the hope here is that if we haven't made any mistakes, we can take now these 4 terms, which is a nice composite number, these 4, and do factor by grouping. So grouping the first 2 terms and the last 2 terms, which this is sort of one of those situations where maybe you wrote it 10x and 9x, in which case you'd have to factor the first and third, right? You'd have to group those 2 together and then group 2 and 4 together, right? So again, if it doesn't work the first time, try a different combination, because sort of there's a lot more sort of happenstance here by how you happen to write down your order. Here, right, first and second, third and fourth, factor out our common term. So in the first part, we're factoring out a 3x. Second part, we factor out a 5. Again, that gives us 2x plus 3 in both. That's how I know I did it right. Factor out that piece to get the remainders. So I have 2x plus 3, 3x plus 5. Everything works, okay? All right, so let's look at another example to sort of see this top to bottom again. So let's say we have something like 2x squared plus 8x plus 6. So same deal, a is not 1, so we take the a and the c terms, we multiply them together, that gets us 12. Find the sort of various factors of 12. Again, you would consider positive and negative, but here, because this middle thing is positive, I'm going to want them to both be positive. So my factors are 12, 1 and 12, 2 and 6, 3 and 4. I want 2 of them that add 8. 2 and 6 are my pair. So then I'm going to split 8x into 2x and 6x, right? So here, right, my 8x became 2x and 6x. And again, with the way I happen to write it, I'm going to group the first 2 terms and then the last 2 terms. That's my grouping. But if I happen to write it as plus 6x plus 2x, then I group the first and the third and the second and the fourth. So again, sort of try whichever one and try the other one if it didn't work. And that will get me, right, factoring out common factor here, factoring out the 2x and the 6, and then factoring out the common x plus 1. Again, I know it worked because I got the same thing. It gets me x plus 1 times 2x plus 6, and it's factored. Okay. All right, so what do we do? Well, we talked about the AC method, right? This idea of sort of taking a quadratic form, or quadratic in particular, right? A quadratic polynomial, where the a is not 1, because when it's 1, we can use the coefficient method. So if it's not 1, we multiply a and c together and then use that sort of pretending that that is the new c term doing a factor by coefficients. We want two things to add to that new number, but still add to the b that we had. And those two numbers end up being how we split b apart in order to have 4 terms that we then factor by grouping. Okay? So that is that.